Hi everyone. In this class, we are going to discuss the most important topic in Unit 2, that is Shortwave Diathermy. So, in this class, we will be discussing right from the basic introduction of what is meant by Shortwave Diathermy and its different types, and also we will be discussing the different mechanism, that is the basic mechanism which is being involved in heat production or heat production effect in Shortwave Diathermy, and also we will have a deep understanding of different methods and techniques of Shortwave Diathermy applications. So let's start with the basic introduction of what is meant by shortwave diathermy. So the diathermy itself, the name stands for dia in the sense deep inside. Athermy is the heat. So we are going to produce a localized therapeutic heat inside your body tissue by using radio waves of high frequency. This is what shortwave diathermy machine does. So the reason for using such shortwave radiation is that when you compare to other radiation, electromagnetic radiation, the shortwave radiations have very good penetration power, and also we have a different bands like longer bands, middle bands, and a short wave. The reason to choose the short wave is that the other two bands will induce the muscle excitation and will create the unwanted effects. Okay, that is the reason we are going with a short wave radiation, because it will not involve with unwanted muscle excitation or a muscle interaction. So that is the reason we are going with the optimized radiation, especially in the frequency range of 3 hertz to 300 megahertz. That is the wavelength in between 1 meter to 100 meters. So if you see in the physiotherapy department, where you can see the shortwave diathermy machine which is being used in the frequency range of 27.12 megahertz, which is optimized level, and wavelength of 11 meter, which is being recommended or highly recommended to be used for therapeutic effect, that is for pain relief or other joint or some other muscle related problems. So that is the all about shortwave diathermy machine. So basically there are two types of shortwave diathermy machine. That is, one is you can work with the continuous shortwave, or you can have other type, that is a pulsed shortwave. This is type of the way how you are giving, how you are delivering to the patient. If you are giving without any interruption continuously, the heat, if you are producing the heating effect inside the body, means then it is a continuous short wave. Or if you are giving the radio frequency wave in a interrupt manner, like for 1 is to 2 or 2 is to 2 is to 3 in this ratio, then you can have a pulsed effect. The in single time you have a heating effect, and then cooling effect, then you have heating effect. So in this train of heating effect will happen in case of pulsed short wave. So let's see how this heat production is happening inside the shortwave diathermy. So as we are discussing the shortwave diathermy, if you take any diathermy irrespective of any type, this diathermy is anyway going to produce the heating effect inside the body. That heating effect will improvise the blood circulation, and then it will treat the particular area which is need to be treated, right? So that is the reason we are inducing the heat, that is rising the temperature over the targeted area by applying some sort of high frequency waves. So in case of shortwave diathermy, we will be sending the waveform frequency range of 27.2 megahertz, as we discussed already. So when this waveform interact with these muscles, so the muscles the muscles inside the I mean ions inside the muscles will undergo a few reactions. That reactions will end up with heat production or rise in temperature over the targeted area. I will tell you how it's happening, because if you take any living tissue, it consists of the three types of molecules. One is charged molecules, dipolar molecules, and non-polar molecules. So when you passing the radio frequency to the tissue which contains these different types of molecules, will undergo the interaction. So if you see for example, you can see the vibration of charged molecules, or you can see the rotation of dipolar molecules, or you can have a dispersion of non-polar molecules. So the charged particles, the mostly the ions are certain proteins. If you see the dipolar molecules are nothing but water and some other proteins, and non-polar molecules are mostly it could be the fat cells. So when you have the interaction or passing of the high frequency waveforms, and that waveforms increase the internal kinetic energy of these ions or the cells, so which will end up with oscillation or vibration or rotation, so which will produce the heating or rising temperature in the particular area. So as a result, you can see heating effect will happen, so which will enhance the blood circulation over the area, which will further induce the a treatment effect. Okay, so this is the actual mechanism or the heat production mechanism happening when we are posing the short wave diathermy. So I have given the clear picture of how this rotation or vibration of ionical molecules or dipole molecules is happening when we are posing a high frequency alternating current. So if you initially it will be in resting state. When you are once if you are posing the high frequency alternating current, it will interrupt these charge ion particles. In first case, if you see the charge ion particles will try to move towards in a opposite direction, so it will try to have a movement, that is under the influence of oscillating electric field. This movement to and back will induce what heat dissipation, that is rising temperature over that area. In second case, again you have a dipole rotation when we have influence of oscillating electric field. So these dipoles will start to rotate based on the influence of oscillating electric field, that is the applied high frequency alternating current. This rotation again will dissipate some amount of heat because of the action of high kinetic energy movement. So these heat dissipation will produce the heating effect over the target area. That heating effect will yeah, will dilate the blood vessels to increase the blood flow. So once the blood flow is increased, you can have a cell nourishment, and then other proteins which is present in the blood will reach over the targeted area to have a repairing mechanism or treating effect. So this is the actual mechanism, or the molecular reaction is helping under the influence of high frequency alternating current in terms of producing heat inside the body to promote the healing effect. So next class we will be discuss what are the different methods of shortwave application. That is two methods: capacitive method and inductive method. Thank you.